Hello guys, we are undergraduate students from Universiti Sains of Malaysia from School of Mechanical Engineering. We are from Group M11. This is our Mechatronics project. So I would like to explain about purpose and the objective. So our purpose is to design a material handling process that can put 8 ping-pong balls into a container using a Raspberry Pi microcontroller with Python programming. Our objective, we have three objectives. Firstly is to develop a material handling system by integrating various sensor and actuation system using Raspberry Pi microcontroller. Second, to create a handling container that is made by eco-friendly materials to collect the ping-pong balls from material handling process. And lastly, to determine operational material handling system that can be performed by the Python programming. So I would like to show you the apparatus of our project.
Did you and Jupiter conspire to get me? I think you and the moon and Neptune got it right. 'Cause now I'm shining bright, so bright, bright, so bright.
I would like to explain material process of our project. First, I will explain the basic part of our project. As you can see here, this thing called PSC is provide power supply to other components such as proximity sensor, pneumatic valve, and relay. Okay. These two relay will control the conveyor belt's direction. Okay. The first relay will move the conveyor belt to the right, and the other one will move to the left. So to demonstrate the actual process, first we put the handling container here. Then we start the process. Okay, the conveyor belt will slowly move to the right, and then the sensor will sense the metal on the handling container, and it will trigger the pneumatic valve, and the ball will drop to the handling container. Then the conveyor belt will continue move to the right until the other sensor detect the metal, and it will trigger the pneumatic valve, and the ball will drop to the handling container. After that, the conveyor belt will move to the left direction, and it will repeat the same process until all ball drop to the handling container. Yes.
Hello, my name is Haziqah Izzati Binti Rozali. I will explain about the material that we use for the box. Firstly, we use a cardboard. Cardboard is a heavy-duty paper-based product having greater thickness and superior durability, foldability, rigidity, and impact resistance. So next material is plastic binding cover. Has enough rigidity cover to be sturdy and smart cover, but not so thick as to affect overall bulk of the box. Next is the paper. Paper, it is used for finishing, for example, to wrap up the cardboard and to seal the box of the vertex which is not covered yet. So lastly, aluminum sheet. Aluminum sheet, it is used to detect the sensor of the solenoid.
Hello guys, I'm Wu Feng, and now I would like to explain the overall circuit of our project. This, as you can see, there are 9 main parts of our component, which is the PLC power supply, left-right sensor, top-left valve that control the solenoid, and the left relay, right relay that control the conveyor belt. So for the first part, the sensor, there are 3 wires that connect the sensor, which is a brown wire, black wire, and blue wire. Brown wire acts as a live wire that connected to the PLC power supply to get the power supply. And the blue wire is a ground wire that connected to the negative terminal of the PLC and the GPIO, in a ground GPIO. So, and the black wire is a neutral wire that connected to the GPIO pin in the Raspberry Pi. And because the sensor is an input component, current will flow from the PLC to the GPIO pin. So we have to connect it to 4700 ohm resistor to step down the voltage. And for the second part is the top left valve that controls the solenoid. As you can see, the red wire of the top left valve is connected to the PLC to get the power supply, and the black wire is connected to the solenoid terminal in the interface circuit. And this solenoid terminal is connected over the GPIO pin terminal here, and is connected to the GPIO pin at the Raspberry Pi. So, and the ground wire of the interface circuit is connected to the ground at Raspberry Pi and the ground at the PLC also. So what is interface circuit? This is the interface circuit that we use, and we didn't use these two as there are some problems over there. So we use this and this. The interface circuit is a circuit that connected the transistor together, and when you connect it as the circuit, like I said just now, it actually look like this. For the valve, that the 24-volt power supply is connected to the valve, and the negative terminal is connected to the transistor, NPN transistor. And this GPIO acts as a switch to control the flow of current of the valve. So when the GPIO gives signal to the transistor, the current flow over here, and current can flow from the 24-volt to the valve that controls the solenoid and flow to the ground. So it's an on for the solenoid. And for the third part is the relay circuit. It is actually same like the valve circuit. Okay, and this is the overall circuit, and thank you. That's all for my part. Thank you.
Like a small boat on the ocean, sending big waves into motion. Like how
we are going to connect Raspberry Pi with a Python tree. Since Python tree does not have a GPIO function, we need to input the GPIO, which is a RPI GPIO as GPIO. And GPIO stands for the general purpose of input and output. Since Python tree does not have time function, so we need to input it. And the form system input exists also. So before we proceed to the process, we need to define all the sensors, valves, and the relay. And left sensor is connected to the GPIO 14, right sensor 15. Top left valve to the 6, bottom left valve to the 13, top right valve to the 19, bottom right valve to the 26, left relay to the 16, and finally right relay to the 20. So we need to set a mode for whether this valve, relay, and the sensor, which is the input or output. So we define that the left sensor and right sensor is the input, and the rest of the valves and the relay, which is the output. So before we started, we are going to use our true function in order to run the process. So the conveyor moving to the right when the started, and the left sensor is activated, we will continue the script in the left function, as mentioned later. If the right sensor is activated, we will continue the script in the right function. Else, rainbow function is not triggered. This is the conveyor will moving to the left, and top left valve, bottom left valve, top right valve, and the bottom left valve will excluded. As I mentioned just now, when the left sensor is activated, it will continue a left function script. So the conveyor will stop moving, and the bottom left valve will be retracted in order to let the ball drop down into the box, and followed by the bottom left valve excluded, top left valve retracted, top left valve and excluded. So this motion is repeated one more times in order to let the ball drop down again. So afterward, the conveyor will moving to the right. So when the right sensor is activated, it will continue the right function script. So the conveyor will stop moving again. So it followed by the bottom right valve retracted in order to let the ball drop down into the box. And continue by the bottom right valve extruded, top right valve retracted, top right valve extruded. This motion is repeated one more time in order to let the ball drop down one more time again. So finally there are 4 balls in the box. So afterward the conveyor will continue moving to the left and trigger again the left sensor and it's run left function again. So this process is repeated 2 times. So finally there are 8 balls in the box.